Thanks a lot. So I'm Kristen. I'm a neuroscientist and a physician, and I'm really happy to be back here in Boston. So I was a postdoc just across the river at MIT for a while, so it's nice to be back. And I'm going to tell you a story about reprogramming brain aging. So I'm going to try to convince you that brain aging is a program that leads to neurodegenerative diseases that we can reprogram it using drugs and lifestyle interventions. And in a nutshell, what my company NeuroAge does is we're a tech bio platform, and we have a customer facing test that can tell you how old your brain is and your future risk of Alzheimer's disease more than 30 years ahead of time. And the information that we're gathering from that test, the not so secret, is that it is providing really valuable data that we need for our mild cognitive impairment and AD biomarker and therapeutics program. And before I tell you how we're doing that, I'd like to tell you a little bit about why we're doing that. So these are my grandparents, and at the end of her life, my grandmother suffered with Alzheimer's disease. My grandfather took care of her in the home, and that had a really big impact on me as a child, led me to dedicate my life to coming up with better therapies for Alzheimer's. It's also a very common story. More than 60 million people worldwide have an age-related neurodegenerative condition. And as we get better at treating other diseases, this number is just going to keep increasing. And a little bit of background, all neurodegenerative diseases are different flavors of the same thing. So it's death of neurons in particular brain areas. So if the neurons die in the hippocampus, that's Alzheimer's. If they die in the substantia nigra, that's Parkinson's. If they die in a particular part of the spinal cord, that's ALS. And for the last 20 years, large pharma has really pursued a certain single strategy to treat these diseases. So they're targeting toxic proteins that build up in or around neurons, amyloid plaques, neurofibrillary tangles. This saw a graveyard of failures until recently, when we've actually had a couple of wins. Eli Lilly and Eisai and Biogen with antibody drugs that remove these amyloid plaques. They work about 30% of the time. They have some bad side effects, including brain bleeding and swelling in a number of people. And I'm happy at the break to talk more about amyloid, but my thinking on this has really evolved. So I think that amyloid is really a risk factor for Alzheimer's, not the single cause. And that in the same way that we're treating cholesterol to prevent heart disease, we need to treat amyloid earlier to as a risk factor for later Alzheimer's disease. But there's a real need for segmentation and for other strategies. So what I've been studying for the last 20 years are the changes that are happening in normal brain aging in humans. Hallmarks of brain aging, everyone's familiar with hallmarks of aging in general. There's some that are specific to the brain, mitochondrial dysfunction, DNA damage, loss of synapses, changes in neurotransmitter signaling, and then inflammatory processes in glia. And upstream of all of those changes are really a group of master regulators that control those transcriptional changes. And the most famous of those are the Yamanaka factors, but there are additional factors as well that control brain aging in particular. And those are the proteins that we're identifying and targeting. So if you zoom in on what these transcriptional changes look like, they really do look like a program. So this is human prefrontal cortex. People die, they donate their brains to science, we get those brains. And these are expression of two Alzheimer's related genes. Less calbindin is predicted to cause Alzheimer's, more GFAP is predicted to cause Alzheimer's. And you can see that we're all on a trajectory in our brains pushing us towards dementia. And some people are outliers. So you can see that some people have levels of calbindin, maybe they died at 70, but look more like a 50-year-old. And those people are predicted to be protected. We can collapse those genes, all 1,000 of them, down into a single score that we call NeuroAge. It's highly predictive of chronological age. And again, you see this delta age. Some people are older or younger than their chronological age. None of that would matter unless we tied it to disease. So a big problem with these aging clocks is, what are they actually measuring? Are they clinically relevant? So we performed a large longitudinal study of adults followed for the last 15 years of their life, and they agreed to donate their brains at the end. And what we showed is that people that were 5 years younger in their brain aging, so brains look 80 when they're 85, were 6 times less likely to have Alzheimer's in the future. This is even if they had ApoE4, other genetic risk factors. This is really, so we published this paper in 2019. You can read more about it, but really echoes what Tony Weiss-Corey was saying yesterday. We see very similar things to what he saw with proteomics. So you can't take a piece of someone's brain that's living. So we needed some way to translate this into living cohorts. So some of our cohorts had both brain and blood, and we're able to create a brain-specific clock from blood transcripts. So 52 transcripts are actually predicting those brain ages. So you go to the doctor every year, you get your cholesterol checked for heart disease, you get your glucose checked for later risk of diabetes, but you have no way to check your brain aging. And so that's why we created the NeuroAge Test. It's a multi-modal, multi-omic predictor, and it can tell you how old your brain is. It incorporates those blood RNA markers, as well as brain MRI for brain volume and cognitive testing online using our NeuroGames. We put that together into a super predictor using AI, and we can give you a brain aging score. So this is Max. Max is 55. He has a NeuroAge of 51. He's 41% less likely to have dementia in the future than someone else his same chronological age. And so this is the most common question I get: how do we reverse our brain aging? So we know some things from the literature already: diet, exercise, sleep, community, reducing stress. There are some evidence from the literature for omega-3s, coffee and tea, GLP-1. I don't know what that doesn't do at this point. And we also are giving folks personalized recommendations. So putting out surveys, learning what they're doing to drop their NeuroAge, and then we can feed that back to people that's specific to their genetics and biomarkers. So, you know, is this test actually able to move with these lifestyle interventions? So I'll just give you a few examples. This is a paper from a friend of mine from med school, came out last year. Just 25 extra minutes of exercise a week, people were actually able to increase their gray matter volume on MRI. So they're growing their brains back. And this is N of 1, so take it with a grain of salt. But this gentleman is an entrepreneur in Florida. He had 2 copies of the ApoE4 gene, so he's very high risk. Tested positive for amyloid on both blood test and PET scan, and then underwent dramatic lifestyle changes, upped his exercise a bunch, and came back, got retested, and was able to test negative for amyloid, which is really incredible. And then Dean Ornish, who is a physician, had this randomized control trial that came out this year showing his lifestyle interventions were able to decrease progression of AD and mild cognitive impairment by 18% using lifestyle intervention. You can try our demo online. I won't go through that now. And then ultimately what we really want to do with all of this information is, if you have a multimodal, multi-omic data set, you can use Mendelian randomization to then identify causal factors that we can drug. And we've started working on that, so not a whole lot of information I can disclose now, but we have 2 lead therapeutics that we're working on. One's a small molecule, one's an antibody, and one of them has already gone through a phase 1 trial, and so we're working with a potential pharma partner to collaborate on that. And with that, I'll take questions. Longevity Summit at the Buck, this is a discount code for it and for the NeuroAge test, and I'm happy to chat with anyone on the break.
Thank you, Christine.